you guys able to hear me? वापस कराना है क्या वो stand up, sit down? नहीं ना? करना है? Okay, I had that planned for my session, but आपने कर लिया, so thank you. Cool. So, how many of you attended the talk just before this? Lunch के पहले जो रोमिल का हुआ? Amazing, right? So, how many of you are excited about where the entire, web is going? How the, web is, moving forward? How many of you are excited about it? Excellent, excellent. So, I am a huge fan of AI. I have been betting really huge on AI. I use AI for everything, right? So the day ChatGPT was announced and I put in my first prompt and saw, "Arey, ye to kuch bhi kar sakta hai." I felt I can do anything. In fact, I was just talking to someone and they asked me, "Which tech stack do you work on?" I said, "Sab kuch AI hai, just like mere paas maa hai." I feel exactly like this. Mere paas AI hai, main kuch bhi kar sakta hu. Right, and again, this image generated by AI. My LinkedIn posts, if you follow me on LinkedIn, generated by AI. This entire slide deck, which slide should come when, generated by AI. I do everything and anything with AI, right? But then, one day I wanted to analyze my bank statements with generative AI, and I thought, is it really a good idea for me to upload my bank statement on chatgpt.com? And I wasn't very comfortable with it. How many of you have tried doing this? You guys have uploaded your bank statements to ChatGPT? No. Would you be comfortable doing it? No. So then उस टाइम पे मेरे अंदर का डेवलपर जाग गया. I was like, अरे यार, ChatGPT है, बहुत सारे open source models है. So why should I not try and run a local model? Take an open source model. I did what any sane developer would do. I spent a lot of sleepless nights trying to get it to run on my laptop. And I was able to do it. Now there are a lot of really amazing tools that kind of help you do it. But back then, about 2.5 years ago, this was a really big problem. Running models locally on your laptop was really problematic. I just missed this. So right now, there is this amazing tool called Ollama. How many of you here have heard about Ollama? Excellent. So before I even go there and, to help me decide what to talk about, how many of you here are web developers? Excellent. You guys understand what, basics of HTML, CSS, JavaScript, how it works in the browser? Anyone here who does not understand it? Excellent. I have a really good crowd then. So there's this amazing tool called Ollama, which you can just install on your Windows, Mac, Linux, whatever app, whatever machine you have. You just run Ollama, you run the command, and it'll spin up an open source model for you. What is a model? वगैरह उस पे आते हैं. I'll tell you everything about that. But you can run it locally on your laptop. And I was happy. I was able to finish my use case of analyzing my bank statements or analyzing any other personal documents. I wanted to, I got a blood test done. I wanted to see agar uska report mein kuch aaya hai kya. I was again not very comfortable uploading it to ChatGPT or any other, AI platform. So I used Ollama to do that, and I use Ollama for a lot of other local things I do. Right. So this is Ollama running. I run it. I put in a prompt which says, say hello to everyone at GDG Ahmedabad, and Ollama, which is running Llama 3 as the model, gives a response, right? But then the developer in me, right, I was very happy about what I did for myself, but I wanted to do this for my users. I was able to do this and achieve this, but what would the users do? People who can't really download, install, and run Ollama. I wanted to get AI to my users on their machines for them to be able to run it locally, right? And so they all can analyze their bank statements and health records and whatnot. So which is when I came across WebAssembly. I'd heard about WebAssembly, but for this, I saw WebAssembly and I was really happy about it. And today, that's exactly what I'm going to talk about. I'm going to talk about how you can use WebAssembly to run large language models on your local machine. Right, so I am Varun. I am a CEO at this company called Therix.ai. I am a founder and CEO there. Therix is a B2B AI or agent orchestration platform, so you can build AI agents. We have a really cool drag and drop UI. You can build AI agents, deploy it into production, run it. I'm also a co-founder at Coditas. Coditas is a clean code focused, clean design, clean UI UX focused generative AI consultancy firm based in Pune. We do a lot. We are a 10-year-old company. We completed 10 years just in the beginning of November. We do a lot of work for clients in the US, in Europe, and also a lot of clients in apna very own Bharat as well. So if you want to check out more about what we do, just visit coditas.com. I also organize some community meetups. I am the organizer of NG Pune. I really like Angular. I have been an Angular developer for a very long time, since Angular has been around probably. And apart from all that, at the core of it, I'm a programmer, I'm a coder. I generally go by I code, therefore I am. If you guys have heard of Socrates, I think, therefore I am. I just tweaked it. I say I code, therefore I am. Right, so that's me. So we were going to, I told you I was able to solve my problem with WebAssembly. So what really is WebAssembly? So WebAssembly is basically a compile target. So let me just read out the statement. WebAssembly is a universal compile target that lets you run code written in any languages. Like it could be C, C++, Rust, PHP, Java, anything. It could be any language. You compile it, and then you get a .wasm file. You just put that wasm file in your browser, and it runs in your browser. As simple as that. So you have a big software that's written in, say, C, C++. You can compile it to WebAssembly and run it on the browser. A really good example of this is something that the folks at AutoCAD have done. You guys have heard of AutoCAD, right? How many of you here know AutoCAD? OK. Some of you don't know that. You guys know Photoshop. Everyone knows Photoshop? Excellent. So Photoshop has a web version. Have you guys seen it? Yeah. So they did not build it again entirely from scratch. They had a lot of stuff written in C, C++, and a few other programming languages. And they were able to port that as it is to the web using technologies like WebAssembly. Right. So to help you understand this better, I have a small demo. So let's just look at how you can write a program in C, compile it, and run it in the browser. I'm not going to write any programs in C. I already have that written. Oh, just a minute. This has kind of messed up my organization. Just give me a second. Yeah, here you go. Cool. So I have this. Is everyone able to read? Should I zoom in a little bit? OK, I'm assuming you guys can read this. So I have a program written in C. It's just a simple hello world program, right? It has a main method. It just does printf hello world. Now, how do I run this program? Simple C program, right? I do GCC. GCC is the C compiler. I say hello/hello.c. And you know what? Let me just go into the directory. GCC hello.c -o. Hello. So that gives me an executable, which is hello, and I can just run that executable, and I get hello gdgdevfestahm. By the way, that's the hashtag, right? So I get this. So this is a simple C program. Now I have written this here. I'm building a web app where I want the same code, right? I don't want to rewrite this again in JavaScript. What do? I compile it to WebAssembly. How do I compile it? For compiling it to C, I used a compiler called GCC, which is the GNU C compiler, which is the standard C compiler that's available in most Linux distros and also now in Windows distros. I use a different compiler instead of GCC. I use a special compiler called mscripten. I'll not go very deep into what mscripten is and how it works and everything. You guys can Google that. You're all smart people. But I'll just show you how to run it. So when you install mscripten, you get a command called emcc. So I can run emcc. I can say, I'll have to give it the, yeah, there you go, just the output. Right, so that's the command. So I have this hello.c. I say emcc hello.c, the same C file, but then I give the output as hello.html. And if you see, over here, what it did is it created a HTML file for me, which is the hello.html. It has written some stuff. We'll see what it is. There's a hello.js that invokes the WebAssembly file, and then there is a hello.wasm, which is the main file जिसके अंदर हमारा पूरा जो C का कोड था, वो ये wasm file के अंदर है. Now, if I want to run this, I already have this running. So this was the directory, hello.html. There you go. So we had a C file. We compiled it into WebAssembly. That C file is now running in the browser. If you look at the network tab on the right, you can see that it actually downloaded hello.wasm over here. And this hello.wasm is exactly what has the main method जिसके अंदर printf statement था जो यहाँ पे आ गया है. But ये तो बहुत simple example था, and because I used mscripten without any flags, it also gave some mscripten branding. By the way, that's the compiler, mscripten, right? On the top that you see. It also gave all that branding. Let's take a slightly more complicated example. Complicated or not, but yeah, let's take a slightly more difficult example maybe, right? So instead of hello, I have a Fibonacci.c, right? You all know what Fibonacci programs are. ये program जिसने भी engineering किया है या 10th or 12th में C++ सीखा है, सबने लिखा रहेगा. Write a program to generate the first n Fibonacci numbers. That's exactly what I've written. This is a C program that generates the first n Fibonacci numbers. Right? इसको GCC से compile करते हैं. GCC Fibo. I'll have to. I go into the directory GCC Fibonacci.c -o. Let me just do fib. There you go. I have a .fib. उसको मैंने run किया. It'll ask me enter the number of Fibonacci terms to calculate. I say 10. It gave me the first 10 Fibonacci numbers. ये तो सबको पता है, सबने किया है, right? Now, what if, assume that instead of generating Fibonacci numbers, it was a very complex thing, जैसे maybe image edit करना है या image crop करना है or something else that I've already written. This is already there. People are using this. Now I want to port it to a web version of the same thing. What I do is I add a very small statement to the same file, a small macro, where I say, अगर ये mscripten से compile हो रहा है, then include this method as part of the WebAssembly module that is generated, right? And to do this, the command is also a little complicated, so I'll just copy and paste it. You can, again, go to the official mscripten docs and understand what's going on. But at a very high level, what we are saying is, from the C file, generate a WebAssembly module. Make sure that this particular method is exported as part of that module. That method is called Fibonacci from JS, जो हमने यहाँ पे function लिखा था. Call Fibonacci from JS, which is calculating the Fibonacci number. We just have to call it, export it as part of the module. So I run this method. It generated a Fibonacci.js and a Fibonacci.wasm. I already have an index.html here that is using it. I will come to that, but let's very quickly go to Fibonacci. And this UI is written by me in HTML, plain old HTML. But when I say, if you can see on the right side on the network tab, Fibonacci.wasm has already been downloaded. I can put in the same input here, calculate, I get a Fibonacci number out, right? So this is what WebAssembly does, right? If you want to look at the code of ये WebAssembly के function को call कैसे करते, it's pretty straightforward. All you do is, you load the module and say module.c call. You pass in the function name, you pass in the input. There's a whole, documentation that you can go through of how this is to be done and what happens and everything. I'll not get into that. But समझ में आ गया सबको? You guys understood what WebAssembly is? Clear? Excellent. Now let's go back to my. I lost internet. Just give me a minute. There we go. Okay, so what happened? So we had a C file we compiled it with mscript10, we got a WebAssembly binary, we ran it in our browser. The same C program, .c file, we ran it through the C compiler, we got an executable file, right? So that's exactly what WebAssembly helps you to do, right? But what is it really though, right? Is it a programming language that I write in? Is it a compiler? What is it? So WebAssembly is a compile target, right? So आप कोई भी programming language के लिए you can write a WebAssembly compiler that converts that programming language into WebAssembly. For example, what we saw, mscript10 is for C and C++, right? People write stuff in Rust. Rust is a very new and popular programming language that is coming up. People write stuff in Rust, and they compile it to WebAssembly. Rust even has a framework that lets you compile, that lets you write UI elements as part of Rust code, and when it gets compiled, you get an entire UI. You don't even have to write HTML, CSS for it, right? So that's one. It's exactly like, if you write code in Flutter, आपको वो iOS के लिए भी compile करना पड़ता है या build करना पड़ता है, या whatever you do, you have to do the same thing for Android. If you build a desktop application, you have to create a separate build for Windows, a separate build for Mac, a separate build for your Linux systems and everything. This is exactly the same. Just that we are bringing all of that into the browser. Just like what we saw in the previous talk that Romil said, they are bringing AI to the browser. We are bringing anything that's written in C, C++ or any other programming language for that matter, into the browser. There are a lot of standard compilers you can find on WebAssembly's official site, and then there are a lot of really cool open source projects, and people have been doing really cool things with this. All that is fine, but you'll be like, "Acha Varun, ye sab to theek hai. What has this got to do with AI?" You started your talk by saying, you'll talk about LLMs and SLMs, and WebAssembly bata diya, ab kya? Right, and that is where, like using WebAssembly, you can actually use AI locally, right? And, but before I even get into that, let me tell you guys a little bit about, some common keywords. Building blocks shayad nahi hai ye, but some common keywords to understand what we are about to look at next, right? What are large language models? Large language models are these large neural networks that understand human language, and they do some kind of a next word prediction. And then, you'll say ChatGPT is a large language model. No, ChatGPT is an application that's built on a large language model like GPT-4o, GPT-4o mini, and things like that. 4o and 4o mini are the large language models. ChatGPT is the application. Other popular open source models are models like Llama. You could have heard of Mixtral. You could have heard of Claude from Anthropic. These are all open source models that are available, right? These are all large language models. इसी में there is a slightly, different concept of small language models, जहाँ पे है तो वही चीज़, it is ultimately a neural network, but it is small. It is trained on a smaller corpus, and it is, very small in size. Like if your, good quality large language models are 400, 500 GBs in size, small language models could be a few hundred MBs in size, sometimes even lower, and we'll look at, how that works. Next, tokens. Tokens are, ये जो model है, ये कभी भी जब भी एक output देता है, they give you output in tokens. So whenever you use ChatGPT, आपने type किया, तो वो फर्र करके output दे देता है. देखा है ना? वो directly एक ही बार में output नहीं देता है. It gives you one token at a time. That फर्र में एक जो होता है ना, वो जो है, वो एक token है. Right? So it gives you tokens. A large language model gives you outputs in tokens. Getting tokens from large language models generally is termed as completion. Okay? Because it completes a sentence. You give it a set of input tokens, which is a statement like, once upon a time. उसके आगे वो complete करेगा. इसलिए it is called completion. It predicts the next word. So it completes that entire sentence for you. Right? So that is what completion means. And inference is the act of, getting the large language model or any AI model for that matter to generate an output, right? So to do inference, you need inference engine, right? Just like if you have a PowerPoint presentation, you want to view it, you need Microsoft PowerPoint installed. Just like that, if you want to use a large language model and you want to get it to do completion and generate the next token, you need an inference engine. So where do I get this inference engine? So मैंने जो locally मेरे laptop पे AI चलाया था, I ran an inference engine. Olama that we saw, Olama is an inference engine, right? Olama runs inference locally on your laptop on models that are there on your laptop. Model run नहीं हो रहा है, inference engine model को run कर रहा है. Clear? So these are a few concepts I want you guys to be very clear about. Now, Olama does local inference, right? There are many other libraries that can do that for you. One very popular library which became really, really popular when the entire open source language model thing started is called llama.cpp. Anyone here who has heard of llama.cpp? Okay, how many of you here have used llama.cpp? Cool, 4, 5 of them here. Excellent. So, नाम में ही secret है इसका, llama.cpp है. So it is C++. What does that mean? I can use WASM, I can use mscriptin, I can compile entire llama.cpp into a .wasm module and run it in my browser. हो गया, LLMs are now in your browser. That's exactly what I did. Right, and now, because of that, you can run LLMs in your browser. But before that, let's just have a quick look at how llama.cpp works. So if you install llama.cpp, more or less just like Olama jaise hi hai, you get a llama CLI in which you can just pass it a model. In Olama is basically a wrapper around llama.cpp, right? Olama pura interface अच्छा देता है. Llama.cpp is super raw. Right, so I have llama.cpp. Yeah, there it is. So over here, what I'm doing is I have this in my models directory here. If you see, I have in my models directory, I have a llama instruct model and I have Qwen. I have 2 models that I've downloaded, I've stored here on my laptop. Right, and I use this llama, what was the command? Llama CLI -m, I can pass in the model, I'll pass in this GGUF model, which is, llama 3.21b, I'll pass in the prompt, which says, on a cold and sunny morning in Ahmedabad, right? And I can limit the output to 128 tokens. I can also do more, but so what I've done is I have passed in a prompt और अभी ये completion run होगा with that model. Llama CPP does a lot of things, but if you see here, it completed my statement, which said we were on a cold and sunny morning in Ahmedabad. We were there last month and we decided to try the local cuisine. I remember the first bite of the spicy meal. A dosa was like a taste explosion in my mouth and so on and so forth, right? So this is what the model did. It completed the statement for me. This is what Llama CPP does. And this ran locally on my laptop here, right? So now, how do we get this on everybody's laptop? मेरे laptop पे तो मैंने llama.cpp download किया, install किया, मैं तो developer हूँ. But how do I get this on my users' laptops? That's where WASM comes in, right? That's what I told you in the beginning. So I tried compiling llama.cpp. It's a very tedious process. It's not straightforward. You have to become that, जो मैंने first slide में दिखाया, sleepless nights वाला developer. So there are a lot of people who have done this and hosted it online. They have published libraries online. One such library is WLlama, which is basically an open source NPM package. They have compiled llama.cpp, and they have made it available for anyone and everyone to use. Right, so you can just use WLlama, npm install WLlama karo, you get certain things. You build your web app, and then you load a model, and then you start using it directly. I have a demo for that as well. Let's very quickly look at that. So I call it stories on the edge. So the same thing that we ran in the terminal, we'll run here on the web app. If you look at what all has been loaded here, there is a Llama 3.2 1B instruct. The same model we loaded through Llama CPP CLI, the same model has been loaded over here also. Let me see if I can, yeah, I can zoom in, I can, yeah. Right, so the same model that I used there has been downloaded here. Again, there is wllama.js and wllama.wasm. wllama.wasm is basically llama.cpp compiled to the web version. I have this, I can do the same thing here on a cold and sunny morning in Ahmedabad. It starts with that, and then it starts running the completion. It is a little slow compared to what we saw on, in the terminal, because it goes through a bunch of layers, but there are a lot of ways to make it faster as well. But you see, it is completing. It's doing 1 or 2 tokens per second, but on a cold sunny morning in Ahmedabad city, a 30-year-old man was strolling through the crowded streets. He noticed that many shops were open and the smell of freshly baked goods, and so on and so on and so forth, right? So we can very easily do this. Now, I don't know if you guys understand what happened here. Let me very quickly recap. We took an open source model. We downloaded it as part of a web app. जब website load किया, model भी download हुआ, और वो model website में ही run हो गया, right? Exactly like what Romil told us in his previous session, where Chrome does that for you. Over here, you don't have to rely only on the models that Chrome ships. Chrome, for some time, is still going to be shipping just, Gemini Nano as a model. Over here, you can load any model. I'm not saying that's bad. That has its own set of use cases. This has its own set of use cases, right? So we were able to run a model locally at the edge. At the edges, at the user's device, right? Now, I have something even better. ये तो llama था, right? What I loaded here was llama. But there is a even smaller model that we can run. And I actually created a small web app. You guys can scan this and try it out right now. The same story writer, but with a much smaller 20 megabytes module. Warning, ये 20 MB download करेगा, आपका 20 MB data जाएगा अगर ये scan किया तो, ठीक है? बाद में गालियाँ नहीं देना, ठीक है? But with 20 MB, just by downloading 20 MB, you will be able to actually write a story with a language model that runs on your device in your browser. Once it has loaded, feel free to turn on airplane mode, go offline, try writing a story. It'll still work. It'll work offline. The language model will completely run on your device. Were you guys able to do it? Did you all get a story? So I added a button to tweet that story, but it exceeds the Twitter ka, each tweet length. So I don't think you'll be able to tweet it unless you have a premium Twitter account. But if you do, go ahead and tweet it. If not, share it wherever you want. Cool? So again, recapping what we did. We were able to have a local deployment of a language model, of a small language model that ran at the edge, at the user's devices. I just did a story writer, but the use cases are limitless. Exactly like what Romil said, you can use it for summarizing certain things. You can use it for finding out the user's intent. You can use it for detecting if what the user is typing is safe or not. Maybe you don't want to allow them to post a specific comment on your social media site. You can just analyze if the comment is toxic or not, and don't allow them to paste. You can use a language model right in the user's browser for that, right? And you might not want to build this for consumer apps. This has a lot of applications in large enterprise use cases where people are not very comfortable about sharing their data, putting it on some kind of a cloud somewhere, right? So it is, when you do this, everything is 100% local. It is running at the user's machine. जिस machine में user के पास data है, उसी machine में AI भी run हो रहा है. हम पूरा AI deliver कर रहे हैं. It is not on a server nowhere. As a developer, you can save on GPU costs, server costs, but like Romil said, right now models are still big. good, decent models which are generic will at least be 100, 200 MB right now. So for end users, it might not really make sense, but for enterprise use cases, it definitely makes a lot of sense. So, you can cut out the need for expensive cloud, GPU setups, and finally, user ke paas control hai. It runs on the user's machine, right? So with that, I end my talk, but I want you guys to take away something completely different from this. The way AI, WebAssembly, and web technology in general is going is such that, everything is becoming more and more accessible for us as developers. It is an excellent time to be a web developer, right? Browsers are getting mature and maturer, right? Models are, open source models are available. You can download them, run them on the browser for your user, in your user's browsers. Use this, explore things like WebAssembly, explore things like large language models, open source models, right? And the possibilities then become endless. You can do anything safely, securely, at a low cost for your end users. You can build really wonderful apps. With that, thank you very much. And if at all you guys want to connect with me, this is my LinkedIn. That's the best place to reach me. And yeah, thank you. Have a very good day. Bye-bye.